Hello, everyone. Thank you for joining this session so shortly after lunch. I appreciate. My name is Cornelia Steinauer, and I will present you a strategy and a use case on LIMS-driven lab automation. I'm coming from Vega Informatics, and we're a consultancy, and we will help you building the bridge between business and lab IT. And what do we mean by that? We work, as the name says, mainly in the informatics space, but we cover all the different pillars of excellence in lab and research, clinical development, information solutions, and also CSV and QA. So basically go all the way down the value chain. And we can help you with anything in this space. So starting from basic data infrastructure, going up to data acquisition, data processing, data integration, transformation according to FAIR principles. And we will help you with data analytics, visualization, or even project management, project tracking, data-driven decision making. This is what we do. So we have a very broad expertise in various areas. We always try to be up to date in this space. Vega is 35 years old, so we have some long-term experience, long-term relationships and partners. We also work with vendors, but we were vendor neutral. That is important to know when we help you in your decision process. We have a great team spirit within the team, but also with our customers. So we really try to work as partners. And our idea, our main goal is, of course, to go innovation, full-blown, being sustainable, being scalable, help you in the process of your own innovation projects. This is our footprint. We're based in, our headquarters is in Basel, in Switzerland. But we have offices all over Europe, in Germany, in Poland, in France, and in the Netherlands. And our customers are actually all over Europe, so going up all the way up to the north. Within Vega, we are working in a bit of an initiative on smart automatics, automation, smart robotics. And this is well embedded in the informatics infrastructure within Vega. Also outside, as some of our partners are also partnering with Sila, if you know that. So we're very well embedded in this network. And we try to reach a bit more into the operational space as well of lab automation. So what we can help you with is a bit of the process of a lab automation process, starting from the scoping, very close to the consumer, to the customer. So we will help you mapping your processes, maybe a small one or a larger one, define the automation scope and the automation solutions that could lead to, and capture the requirements, so we can then help you in the process of a vendor selection. We have broad expertise in the field, in the scheduling system, but also the instruments. So really trying to build customized system for each application. Once you have selected your vendor, we will help you then throughout the process, implementation, project management together with the vendor, final designs, FAT, SAT, everything that comes with the game. And if it's necessary, we can also help you with the validation. If you're working in a QC environment, we have some CSV expertise where we can help you with. So, automation, the benefits you're missing. Everyone thinks about high throughput and saving time, and that is obviously one of the largest benefits in a space. And you will have the possibility by parallelizing, miniaturizing your assays to really do that. But at the same time, don't miss out on one of the major benefits, and that is really quality of your data. Because reducing the human error then will lead to less deviations and less rework. So you will have a higher data integrity. And another big advantage is also the better return of investment using your instruments, because you can run them around the clock, and reduced ergonomic pressure on the scientists, so the scientists can really focus on the science. So, where are we? Where do we want to go? So, none of you is probably still in this state, but in reality, this is where we all started out of. So we have plenty of samples, they're all over the space. We have many buffers to prepare, we have many calculations to make, we have all these different analytical instruments standing around, and that requires a lot of manpower. And the one to the left bottom is an AI picture, so that doesn't really exist anymore, but the one to the right rarely exists either. That's the fully connected lab, where you have automated sample managing, sample handling, storage. You have the big cloud on top, which handles all your data. So that's the dream scenario you want to go to. But how do you get from upper left, lower right? But there's so many steps behind, and there's so many solutions behind. It's not just one way. And it really depends on where you are on this process. Are you more to the left? Do you already have some of the things established? Do you have some instruments that you want to reuse? Do you just need a bit of parallelization and maybe a liquid handler and maybe a LIMS system that connects to one of the instruments? So then that's the solution, and that might be good enough for your application. You can also go one step further and have a really fully integrated system. So a scheduler that runs all the different instruments and have that connected to the LIMS. But it really depends on your use case, and at the end it's a bit of a process from upper left to lower right. And it's important that you always, in every step of the process, define where you are. So use case. It's a theoretical use case. It's very much simplified, but it's based on two projects that we have been running in different companies independently from each other. And what I'm going to present you is a bit of the take home and the lessons learned from that, and a bit of a suggestion on how we would like to proceed on these cases. So where are we? We are in a QC laboratory, so we're in a regulated space. We use multiple analytical methods. And our challenge is, of course, that all these samples need reformatting, diluting, plating, controls, replicates, and everything has to go according to GXP guidelines. And sample tracking must be ensured. So all in all, very labor-intense process in a highly regulated space, and you need many people to follow that through. Where do we want to go? Well, we want to automate everything. We want to do the reformatting and dilution of the samples. We want to be able to deliver multiple samples in one batch, but we want to also be able to autonomously start several batches so they can run independently. And that will then enable overnight runs and the full leverage of your instrumentation. And again, of course, we want automated sample tracking and data tracking. So classical solution is a fully integrated system. You would need a scheduler for that, scheduler being represented by the robotic arm, which is the physical interconnection of all your analytical instruments and your liquid handler and your sample storage. But it's also the software that drives all these instruments, and it should be the software that is connected out to the LIMS system. You don't want to connect each individual instrument to your LIMS. You want to kind of funnel this to be able then for the user input, the physical user input, to just go into the sample storage and release the samples into the system to run independently. And the data input, and this is a bit the question we want to address here, where should that go? Is this going into the LIMS or is this going into the scheduler? Which one of those is running the system and running the data? And this is where we want to make the use case to actually run it through the LIMS. And this is in particular valuable in a regulated space, because there you have to work according to GAMP categories. But it's also a general procedure where you think of simplicity and what is already there and what you have to develop. So I don't want to dig into this. I'm not the expert in the GAMP categories, but you know, it goes from 1 to 5 and it gets more complex the higher you get. With automation systems, you have to validate your system. So you're automatically up to GAMP 4. You need some computerized system validation of the instruments of the scheduler as well. But you cannot make it even more complex if you have a highly customized system. And this is where we want to make the case for use a standardized system where you have some configurations already in place, where you can do the dilutions, where you can have the sample tracking already in place, where you don't have to write the scripts. You have that set up in a validated system. In contrary to if you want to do all these scripting and these calculations in a scheduling system, you would have to start scripting. And this makes it extremely complex in the validation process. Immediate wins of this is that you can skip the so-called 4 eyes principle that you need in a regulated space, where second person always had to check on every point that you do in a process, in a workflow, in a data flow. So with an automated LIMS, you have that all up front. You don't need the 4 eyes check anymore. You do have the automated calculations, automated plate design. I mean, often in high throughput screening, for example, you need randomized plates. This is all automated in a system like this. And then you have all that tracked. So go with barcodes and track throughout the system. How do we do that? And that's really just a rough overview, and invite you to come over to our booth and talk to us if you need to talk more details on this. You configure your LIMS accordingly. So you need your batch ID, batch parameters for the samples. That's also for the protocols that you're running in the system, for the liquid handling, for the data analysis, data management, play data out, calculations of dilutions. All this you do in the LIMS. And then on the scheduler side, you need to prompt. That is the start of the systems. You need to prompt your sample in there, and then use only APIs to feed the data from the LIMS to the scheduler. All the information that you need. So here, to summarize, this is LIMS first logic. Have everything in there, simplify, have a slim implementation, review and validation process all in there. In the scheduler, only use parameters. Don't do any scripting there, don't do the calculations there. And only go with API. Really try to avoid manual feedage of data or CSV files or all these kind of things. Just let it run through the APIs. This most of the systems are set up for that, and ask for it if they don't. So to summarize, I really want to make a use case again for defining your goals properly to begin with. That is really, really crucial. Your bottlenecks, where you want to go, where are you in the process, and try to gather your people that are working on the processes, take them in the decision and in the development, because they are the ones that have to use the system. If you don't involve them, they're not going to use it. And then go step by step, start implementing the LIMS procedures, implementing the scheduling, and then connect. Because if you do everything at the same time, it's not going to work. So this is what I want to give you on the way. Just a bit of a picture. This is us. We're a very diverse group of people. We have different expertises in different areas. And the nice thing is we work as a team. So there's not one person doing it all. There's always someone that can do Python script for us, or help us with the LIMS and help us with the ELN. and together we can help you in the process then. Thank you very much. We are at booth 109. Please drop by. My name is Cornelia, and I'm there with my colleagues, Joachim and Matthias, and happy to talk to you there. Thank you very much.